thank you again for inviting me to speak and for the generous introduction at the start. I'm afraid I'm very aware of the time, so I'm going to skip fairly quickly through a presentation. There are quite a lot of slides, and I hope people will be able to review them offline later on. But the subject is selecting effective respiratory protective equipment for SARS CoV-2, and I'm focusing on the words effective and on selection. So running through, I suspect that a lot of this may be familiar to people who are in the occupational health business. When it comes to respiratory protective equipment, there are a range of products available, and these can be chosen according to the hazard, according to the task, and the needs of the wearer. Here are examples of some, and roughly what you might call a sort of 1 to 5 scale of hierarchy in terms of level of protection, and the assigned protection factor, which is used in calculation in particularly situations where there are exposure limits of the protection level needed. When it comes to respirators, you really make a choice. Sorry, I'm just trying to move that ahead. Where you have a balance between such factors as the physiological burden, the logistics and training, and how long you can use the product, also the price, versus the protection level. And in general, the higher the protection level, the more burdensome and the more costly the equipment. So it's a matter of selecting what is needed according to wishes. Filtering face pieces at the far right, of course, are the easiest to use, but offer the lowest level of protection and have a fairly limited usage time before they become difficult to use. SCBA on the left, we don't consider any further in sort of the healthcare side. It offers the highest level of protection. It has limited service time and also is very pricey. But the options for healthcare seem to be in the range of powered air, going down through full face mask, loose fitting powered air, and then half mask and filtering face pieces. So what you need in a workplace, I guess, depends on the hazard that you have, as I said, the tasks and the nature of the worker. Some important points to consider right up front, because in this time, there are a lot of claims, a lot of quick experts in the field. No respirator can provide 100% protection. Any claim is suspect. They don't prevent infection, but a properly fitted, maintained, and approved respirator can reduce the chances of getting infected. Discussion in the respiratory protection community is that surgical masks and procedure masks that do not seal to the face are not considered respirators. That's a quick demonstration there that fitting one's hand over one's mouth is probably as effective for inhalation as a surgical mask. We do recognize that for exhaled particles, surgical masks and other types of masks do have a role. Just some on the right, some things we're not going to mention because they're already discussed or not relevant in healthcare. Trying to keep it simple, really, when it comes to effective respiratory protection, there are 3 F's: filtration, fit, and function. I'm sorry, I'm going to go fairly fast, but you see on the screen there are some of the terms that are associated with those. This is like the triangle of fire. You need all 3 of these to have effective protection. A good filter, the equipment has to fit properly to the face to provide the necessary protection, and the wearer has to be able to function while wearing it. And not in the case of the picture, they actually have to remove the mask to speak effectively and so on. So there are these 3 aspects, and I'm just going to focus a bit on each and give some more detail. Okay, I'm going fairly fast. You may or may not be familiar with the mechanisms of filtration. This is sort of standard industrial hygiene textbook, but it may have been a few years for some people. So in terms of the way filters work, there are generally fibrous mats in the effective areas of filter webs, and there are multiple mechanisms by which particles are removed. Maybe by grazing by, colliding with, or being pushed by airflow, air movement to a fiber, where they are retained generally by electrostatic charge. And what has been an advancing technology over the last 20, 30 years is actually to enhance the electric charge on fibers and so improve the removal of smaller particles. The overall effect of these factors is that a filter is not like a tea strainer or a net. It doesn't filter down to a certain size. And one would note that sometimes you see claims that, oh, but we filter down to 0.3 micron. It's actually more complex than that. And so the filter measurement is made with specific equipment under specific conditions. One thing to mention with these specific charging methods that improve the removal of small particles, oil can dissipate or coat the fibers, dissipate, charge, or coat fibers, and so there are some tests that are requiring oil mist aerosol testing as well as the inorganic salt that's normally used. Sometimes there are distinct classes. And this is where you get some of the classifications that you may have seen in describing filters. But what the effect of these multiple removal mechanisms is in the diagram there, that there are some effective at small particle size, some effective at large particle size. And so you have an issue where instead of a cutoff, there is in fact a minimum level of efficiency. And test standards have been designed so that testing is undertaken at that minimum level. And the 95 in N95 indicates the efficiency at between 0.2 and 0.3 microns, which is the most penetrating particle size in the sort of airflow ranges we're dealing with for respiration. And so at smaller or larger size, the filters are more efficient. And as we learned yesterday, when it comes to things like viruses, they are generally not free in the air, but traveling within droplets. And so the droplet size being much higher than the most penetrating size, we have effectively 100% filtration, if not very close to it, at the typical droplet size that may be encountered in a healthcare situation. Top right, there's a sort of matrix of filter types and efficiency under the NIOSH classifications. That's the approval system we have in North America. N95, of course, is a very familiar term. I would emphasize it's a test standard or test classification. It's not a product. There are several filter designs that can meet N95. The other one is P100. That's generally more found in industry, but a P100 filter is certainly readily capable of meeting healthcare needs. There are other ones in there, and what happened, this classification came out about 25 years ago to deal with the fact that some technologies could not cope with this oil mist. Over time, technology has advanced, and so the capabilities of filters have sort of migrated to the extremes, so that now you will be very hard pressed to find anything else except an N95 or P100 type filter in a sort of filtering piece or negative pressure filter mode. You will generally have to select between those. As I mentioned, P100 is perfectly capable. On the powered air side, till in fact about 3 months ago, there was no choice. You had one class, which was an oil mist tested filter, and went on powered air purifying respirators. Was certainly capable in the healthcare side, but it also had to meet a tough classification for heavy industry where it's clogged up. And that has led to equipment being larger, heavier, and more expensive than it needed to be in healthcare situations. NIOSH responded very quickly to the issues here, and in April issued a new standard for those 100N and 100P classes, which actually will lead to smaller, lighter, and cheaper equipment in healthcare. This is a very new development. They're still actually seeking public comment on that. So this is just something good. The other thing to mention is that there are surgical mask designations, but these are generally for fluid resistance. And when you look at the test standards, they are much less stringent than the respiratory protection standards. And so therefore, for bacterial and blood resistance, there are some products that actually combine both capabilities, and NIOSH and FDA have worked together to issue a common approval mechanism now. There's nothing approved in that area yet, but in the future you will see N95 effort filters. I think on one page I have a reference to those standards. Sorry, just trying to get this to advance. On the fit, and there are, again, there are many factors that determine fit, from the design of the mask and how flexible it is to fit different head forms, the sizing options that are offered, the airflow resistance of the media. Interestingly, there are cases where you may have a more efficient filter, but because it's harder to breathe through, the air channeling through any leak is exacerbated, and you may get a poorer overall level of protection than you would with a lower grade filter. and there's some recent papers describing this. Straps are important. On one point, as has been observed when they have been examining stockpiled equipment and how it has aged over times that may be much longer than the intended storage life, is that when the filtering face pieces are evaluated, it is generally found that it is the straps that fail first, rather than the filtering material. So it's something to bear in mind if you are in a position where you are using old stock, to check the straps as well as evaluating the filter material. Again, there are guidelines on how things should be stored and sampling done on the national stockpile in the US that have come up with information around this. Table below, I won't go through it now, is sort of covering how the features that may fail on storage or on decontamination for reuse of filters and things that need to be checked for that. On fit, I think everybody probably is familiar with the need for fit testing. Just to say there are qualitative fit testing using a hood and a bitter or sweet aerosol, or a quantitative test where a electronic device is used to measure dust particles in the air in the ratio inside to outside the mask. Those two tests are, one or other is used for initial selection of a product or a wearer and for routine retesting on an annual or 2-yearly basis, depending on the where you are. It's not necessary for testing every shift. Came across a case in the UK where they had been doing a qualitative test every shift. They had not been changing the bag between users, and that led to multiple COVID infections in a healthcare team. So for each donning, you practice is a user seal check, which is to cover the filtering element and then breathe in or out quickly to see if any leaks can be sensed. That's about it for fit. On function, there's been some recent work by a group called the Centre for Evidence-Based Medicine, UK-based group, and have been involved in some review papers they've been writing. One relevant one is concerning the use of disposable and reusable respirators and the impact they have on the function of the healthcare worker doing necessary tasks that occur during a pandemic. We looked at standards, we looked at the aspects affecting the fit of the respirator, how the respirators were perceived, and how performance was changed by the respirator use, what tasks were affected. This was a systemic review, and so there is a formulaic method used for that. Right now it's been submitted for publication. There's a preprint link at the bottom, and a lot of references within the preprint that sort of will provide further insight. What was found, perhaps not a lot of this is surprising. There is a need for appropriate fit testing and training, and it is not uncommon that the first respirator tried does not work well, and so one needs to try different models. One cannot go from that seal check and predict proper fit easily. You have to do the appropriate fit testing, and beards, facial hair is a problem with properly fitting respirators. When it came to certain activities, CPR led to failure of fit. There's a lot of energy and movement in CPR, and so that did lead to displacement of a respirator on the face and loss of proper fit. With powered air, that's powered air purifying respirator, there weren't any studies. Sorry, there was no failure rather, sorry, and no studies with elastomeric respirators, but it has been observed that certain activities like that can be a problem when wearing filtering face pieces. When it came to standards and practice and training, I think the key thing is that repeated training was necessary. It wasn't good enough to do it once a year or just when the person started in their job. Repeat training was essential in order to ensure that safe and good fit was obtained and safe use of respirators continued. Doffing and donning is a key aspect, of course, to make sure the respirator is worn and fitted properly, but also during doffing to make sure there is no cross-contamination due to loss of infectious material from the respirator itself. On the impact on performance, there were some studies using simulations, and it was noted that intubation was minimally affected by respirator wear, but there were some problems with vision and hearing, as might be expected, and that depends on the nature of the respirator. On communication, there is a drop in speech quality. Again, not surprising. There are speech transmitters incorporated into various kinds of the elastomeric masks, and so this will aid that situation, but it is, again, going to be an issue with some kinds of respirator. On comfort, simple fact, respirators are not comfortable to wear, and it was actually noted that it was higher discomfort with the elastomeric FACEPIECE and the powered air systems than the filtering face respirators. It was reported that half of users were unable to wear for a full 8-hour shift, but that was a highly variable observation.
Simon, it's Kevin here. I'm just wondering, I just wanted to leave room for at least one or more questions, and just wondering if you could wrap up soon. Thank you.
I will, yes. Okay, thanks. Okay then, overall there's a balance accepted between discomfort and protection. On standards, there's more slides, but what I will cover simply to say there are performance standards, and there are a range of these, and in supplementary slides you will see more information about these. So that now with shortage, there are non-standard or non-familiar standards in use, and some of these are better than others. When it comes to selection, there are standards, and particularly good standard in Canada guiding selection, that have existed for some time, but also emergency changes under the pandemic planning, links there to Canadian and US connections. Canada does have a very good standard for selection, use and care of respirators, which includes a system for selecting appropriate respirators for biological aerosols. Again, that's detailed later. And just to say a few current issues to be aware of. It is possible and now allowed under various authorizations to use any industrial respirator in healthcare. Extended use and reuse is a fact, and there are technologies, again, rapidly developed for that. And things to be aware of in using unfamiliar respirators like counterfeit products, or in particular products that may fit a standard but do not fit well to the wearer because of different head shapes between say, Asia and North America. So with that, I'll stop there, and I guess we'll move on to questions. Thanks.
Thanks, Simon. And I might, if you don't mind, if you just leave that slide up that you just had up there, the one that you just had up. And I thought I'd just lead in with a question from Marianne. And first off, I want to thank all the speakers. And we haven't really got much time for Q&As, but I just wanted to bring everyone's attention to a question in the chat box from Marianne Levitsky. And I'm just putting this to all the speakers, maybe Lisa and yourself, Simon. And I know we're talking about the hierarchy of control. So really we should be focusing on, engineering controls more so than respiratory protective equipment, which is the last line of defense. But this question has to do with, in the webinar yesterday, Dr. Conley said that he had evidence and experience showing that healthcare workers wearing surgical masks to care for COVID patients were not infected. Can you comment on this in light of what is known about the effectiveness of surgical masks in comparison to N95s and other approved particulate respirators? Do you think that good ventilation in hospitals, in light of Dr. Bross's comments on infectious dose, may explain this? Maybe if I go to you, Dr. Bross, first, if you don't mind, if you're still here.
Sure. It's hard to prove a negative. So I'm sorry I did not listen to Dr. Conley's presentation, so I don't know what data he's basing that on, if it's anecdotal. The studies that have compared surgical masks and respirators, the clinical studies that have compared those two for influenza and influenza-like illness most of them have not had a control group. And so it's very, the conclusions have often been that those two types of, personal protective equipment, I use that term broadly, are equivalent, but it is actually very likely that The respirators didn't work because they were not fit tested or were not worn, and that is a problem. If you don't wear a respirator when you have an exposure, it will not work. And it's very likely that surgical masks, you know, didn't work. So you would get similar kinds of, you know, performance with respect to those two. But if you don't have a control group, then you really, and you don't compare what happens without either of those interventions. You really can't make a whole lot of conclusions about one being just as good as the other. What you can say is that neither of them was different from each other. But that doesn't mean that they're similarly as good. And if you actually look back at some of those studies, you'll see that the rates of illness are similar to what you would see in places that are not using either surgical masks or respirators during influenza, seasonal influenza. So I guess I would say that I don't think there's very much evidence that surgical masks provide any kind of protection. And as Simon just mentioned, they are not respiratory protection. They do not fit. Their filters do not work very well. I've measured the filter efficiency of surgical masks. It's all over the place, but none of them come close to being what we would expect for a respirator filter. So there is very little chance that they provide very much protection, and probably what is happening is simply by chance, or maybe someone is not in the room long enough, or, you know, so I don't think that anecdotal evidence is appropriate, and I don't know of any clinical evidence that suggests that your surgical masks are appropriate.
Thanks, Dr. Brossi. We've got 1 minute left. Simon, would you like to comment on that?
I just comment on that question. It is also a factor that you're looking at the working hours, or trying to control with one type of respirator or a surgical mask during working hours. You have no control over people getting infected outside work, or again, as Dr. Brosseau mentioned, whether they're properly wearing a respirator, because they're not going to admit that they're not wearing it properly or wearing it as they should. So this is the comparison I've used is like it's trying to test by make people wear a seatbelt 1 day a week, if seatbelts are actually effective in reducing road accidents, road injuries, because you have so little control over this. And there have been multiple studies, and when statistical methods have been applied, as Dr. Brosseau said, you don't get a good conclusion out of that, even if sometimes papers have claimed it. And sometimes the authorities have grabbed onto that information and sort of taken it into a policy.
Great. Thank you very much.